Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, I will go over 2021 AIME 2 number 3. And I want to change up the styles of this video a little bit, and I will talk a lot more, but I will write a lot less relative to my amount of talking, but the overall amount of writing will be the same. You can put your feedback in the comment section below as well to see if you like this video style a bit more. Alright, let's just get straight into it. Find the number of permutations x1, x2, x3, x4, x5 of the numbers 1, 2, 3, 4, 5 such that the sum of 5 products is this thing. If we examine this very, very closely, we would see that, x1, x2, x3, x2, x3, x4, x3, x4, x5, x4, x5, x1, x5, x1, x2. Whoa, this is a cyclic expression, which means that if I have x1 is equal to something, that is equivalent to x2 equal to something. Let's say x1 is equal to 1, and let's say there are 10 possibilities here. Then if I get x2 is equal to 1, then it will have the same amount of possibility because x1 and x2 essentially does the same job, has the same position in this expression. Which means that we can first assume one number is in one place. However, you cannot assume 2 at the same time because it will break. And if we assume 1, let's say x1 is equal to 1, then we will see that x2, x3 plus x2, x3, x4 plus, you will see that it will no longer be symmetrical or called cyclic, which means that this cannot be used. You can only assume one number at a time. Well, since it wants us to be divisible by 3, we see that there is already one number in this permutation that is already divisible by 3. That is 3 itself, which means that if we let x1 to be 3, we can get rid of a lot of the terms. Well, if x1 is already divisible by 3, or x1 is 3, then all of these terms would be divided by 3. This term, x1, no, that is already divisible by 3. We don't want it anymore. This x1 as well, and this x1 as well. And we'll find that we will just be left with x2, x3, x4, plus x3, x4, x5. And it is a lot simpler notation here. A lot simpler expression that we can deal with, and we can deal with this straight up, just bash this, and it wouldn't even take that long relative to the amount of time AIME gives you. Well, let's see. We have 1, 2, 4, and 5 left, since 3 it is taken over here. We can draw a simple chart to help us. Let's say this is x1, x2, x3, and there is an overall chart. Well, let's name this x2, x3, x4, x5, and let this be this sum that we want to calculate. Well, the sum divided by 3, the remainder of it. Well, I'll just write sum here. Sum mod 3. It is the notation that we want the remainder when s is divided by 3. All right, let's take a look. How about let's just try 1 first. Well, 1 seems cool. Right. 3, x3, maybe we can try 2 Maybe you can try 4 here, 5 here. Well, that will give you 24 options to test with. And we don't want to do that because that is more tedious than it needed to be for straight up bashing. We can further separate this 4 numbers into 2 groups. One group 1 and 4, the other group 2 and 5, because when we're talking about divisibility and mod, 1 and 4 basically does the same thing under mod 3. Which means that we can just have the number mod 3. All of these as mod 3. Well, if we know that we don't have 0 mod 3 because 3 is taken and there's no other number that is divisible by 3. Let's say we start with 1. If we have 1, 1, 2, 2. Let's see. 1, 1, 2, that's 2. 1, 2, 2, that's 4. That seems to work. That's 2 plus 4, which is 0. Or 0 when divided by 3. The remainder of 6 when divided by 3 is 0. Well, let's say we have 1, 2. 1, 2. How can we make it work? Well, we have 1, 1, and 1, 2 left. Well, how about let's just try both. 1, 2, 1, 2, 1, 2, 2, 1. Okay. That seems promising. If we have 1, 2, 1, then that would give us 2. If we have 2, 1, 2, that gives us 4, which also gives us 0 or divisible by 3 here. However, in this case, we will have 4 here and 4 here, which means that this case, it will give us 8 or 2 when divided by 3. Well, now we've talked about 1, 1, 1 and 2. Now we have, let's say, 2 and 1. Okay, we have 1, 1, and 1, 2 left. How about let's just try both? And also we have 2, 2, 1, 1. Well, if you look at the chart, this becomes very clear that it is going to be symmetrical. Let's say that this part, this part, 2, 2, 1, 1 is going to be perfectly symmetrical than this. And we want to find basically also a not symmetrical, but we have here that switching these two with these two, we will also find that this, that will be 4 plus 2, which is going to be 0. And this 4 plus 2, also going to be 0. And you will see that this is 2 plus 2, which gives us 1. Well, we only want this, this, and this. How many ways of each are possible? Let's see. Well, because we have 1, 1, and 1, 2, and 2 1s and 2 2s in each, we can, let's say if we have this 2 and 2, we can give 2 and 5 or 5 and 2. So that's 2 ways. We have 1, 2, 3, 4 ways over here, and 2 ways to do 2, 2, and also 2 ways to do 1, 1, which means we get 16. However, don't forget that this is not our final answer, as our final answer is going to be 16 times 5, as we initially assumed x1 to be 3. That will be the same case, same 16 when x2 is equal to 3, but we need to multiply by 5, which gives us the answer of 80. Thank you for watching this episode of Investigation, and I will see you in the next one. Goodbye.